The next thing that we're going to talk about is, remember, we're trying to distribute the energy that is given to the Earth by the sun. One side of the world gets heated because it's in sunlight. One side of the world is cool because it's in the nighttime. 80% of all energy is transformed around the world in the use of wind because of energy differentials. Now, a wonderful example of how wind starts happens along the coast. If you ever go to the beach, which you probably want to be there right now, and you sit on the beach, there's always, or almost always, wind. And so, why is there wind at the coast? Well, it comes from the fact that land and water heat up at different rates, and land and water cool off at different rates. And so, let's take a look at the animation and then I'll go over what we see. In the day, so I'll write day, the land gets hot. The water is cool. Okay, so where the winds are born in the equator, what happens is the air gets heated so hot that the only direction that air goes is straight up. And so this was actually very dangerous for sailors. There were places that were marked off as the doldrums, and it was a very forbidding place because if your sailing ship got into the area where the doldrums were, you were literally up a creek without a paddle. You had no way to move. There were whole ships and crews that were lost that actually entered that area because of misnavigation. And so the doldrums are indicated and thought about as being a very bad place. Now, there's another issue when we talk about the air. As air moves on the Earth, well, air is in the atmosphere, right? But the Earth is rotating. And so if by chance you try to, let's say someone could throw a ball from the North Pole to the equator, okay, and threw something very hard, it's going to travel, and you would think that it goes in a straight line. In actuality, it will travel in a straight line, but the problem is, as you throw it, the Earth is going to move below that thing that is in the air, and from our perspective, the ball that was thrown will look like it curves because the ground is just moving out from under it. An example of that is this merry-go-round. The kids are actually pushing the ball straight, but as it rolls, the merry-go-round moves in a circle and it makes it look like it goes in a arc or a curve. It's not, the ball is not being pushed in a curve, but the ground under it moving, it makes it look like a curve. This is called the Coriolis effect. I have a video that explains it in just a little bit more detail. This also will be seen if you flush your toilet. It spins one direction up here in the north, down in this past the equator, it actually spins in the opposite direction. And so kind of oddball things. And so what we see is the fact that the air looks like it curves around. It's because the Earth is moving under the air while it's suspended in the atmosphere. we're going to get several convections. You're going to get one here above the equator, one here below the equator. You're going to have two more either side to get 1, 2, 3, 4, 5, 6 different little convection currents. Okay? Now, high and low. Anytime air goes up, it's low pressure because of the weight of the air sits on you, creates pressure. But if it's moving up, there's less weight on top of you. And anytime you have high pressure, that's air moving down. So it's weighing on you and falling on you, so it's higher pressure. What's important about these air flows? We have a tendency to go one direction or the other. All right? Now, we erroneously, I believe, teach in textbooks that a certain person found America. Who was the person that found America in 1492? Columbus, okay? And he sailed the ocean blue and he landed in America, yes? Where did he actually land? Where? South America or the islands in the Caribbean. So, he came from Europe. And what he did was use the winds that tended to go west to power the ship. And that means he's probably going to land somewhere around here. Okay? Not at Plymouth Rock. All right? Because the winds up here go towards Europe. And so most of the people who sailed across using wind used what were called the northeast trade winds. And so the trade winds were those people coming over to pick things up. There were pirates in the Caribbean because all the people who had lots of money to buy stuff were coming into the Caribbean, and so pirates wanted that. When you headed back to Europe, you sailed up the coast and you caught all the winds that were going towards Europe, and those were called the prevailing westerlies. And at that moment in time, we had to use the overarching wind patterns to power. Here are the doldrums. If you actually went too south, you got caught in a place where there was no wind to push the ship around. All right, and so these are two patterns that dominate our perspective because we live in that area. Okay, I don't want to listen to that again. All right, the effect of wind, we're going to take a look a little bit more about those 6 cells of wind in this video. And so there are 6 cells complete. And again, we're trying to mix hot and cold air. That's all why we actually have wind. Now, remember, hot air has the capacity to hold lots of water. Cold air can't hold a lot of water. And as we move around all this energy, we're also moving around water, the humidity, which then causes rain. And this is the temperature and the rain are 2 of the main components of the weather that we're concerned about. Now, if you ever lived in Florida, you're always worried about hurricanes. And hurricanes come in from the east to the west. And so we see hurricanes coming this direction. But if you look at the weather that is dominated in America, most of the weather starts in the west and comes to the east. And so there is a dividing line where some of the weather heads in one direction and other weather heads in a different direction, and it's because of these 2 different cells that are competing between the first cell from the equator and the second cell that is right over the U.S. The patterns of movement is almost always west to east over the continental U.S., and then around Mexico, Florida, it's always coming from the east as an overall general pattern. Okay, and so this jet stream, the largest one that we are concerned about is that polar jet stream that really dominates our weather. And so this winter around here, we got like really, really cold. The reason why we got really cold was that this polar jet stream actually dipped really far, even farther than this. It kind of dipped way down. And it brought all the very cold air that was in Canada, and down in Florida, they lost a lot of the crops of the oranges because that cold air was pulled down much more south than normal. And so this jet stream can move up and down and can affect the kinds of weather. And so at times when it might get really warm in the winter down in the south, what happens is this jet stream may stream up and it brings up the warm air into the U.S. And so that jet stream changes a whole lot and actually affects our weather. Also, the fact the winds in the polar jet stream actually affects flying too. If I fly out to California every so often and go down to Atlanta, and the flight from Atlanta to San Diego is about 4.5 hours. But when I wake up and I come back, the flight from San Diego to Atlanta is about 3.5 hours. What is the difference? As you are flying towards California, you have to not only fly, but the wind is in your face. If you hit the polar jet stream, it's really in your face. And so it takes longer to go to California because the winds are coming at you. But if I take off in California and go east, the wind is behind me. Not only am I moving, but the wind is carrying me with the current, much less time. Same distance, the airplane flies at the same speed, about 500 or 600 miles per hour, both ways. The addition of the either extra time or less time is the flow of the air that is pushing against it or pushing it forward.